I'm Dhillon. I'm the CTO at Socrata. It's a real joy to hear from Joy, a customer of ours, tell a part of our story. I'm gonna start off with kind of a little bit broad question here. I think everyone in this room, and certainly everyone I've seen in the public sector, which to us at Socrata, includes governments, including cities, state and federal government entities, as well as multilateral organizations like the World Bank and the UN, as well as nonprofit organizations like the Gates Foundation. But everyone that I talk to and have talked to, fundamentally wants to make society better. We want to increase the quality of our schools, lower crime, increase access to healthcare, all of these sort of things, including increasing trust in government, which is at an all-time low right now. And so, in short, what we want to do is, make society so great that everybody's dancing in the streets. Hello. So what's the problem? Well, in general, there's a relatively small appetite for increasing revenue within the public sector. Whether it's tax increases, it's also hard for nonprofits to raise money because it's a competitive environment. It was also difficult for a lot of cities to access really great talent due to a lot of you folks in the room here. So in short, there's like a limit around money and people. And so is the result as bleak as this image suggests? Well, it turns out there's one thing, of course, that governments have in absolute abundance, and I'm sure you can guess what it is. There's tons of data. So whether we're talking about the data that society sort of uses to describe how we move in the form of transportation data, or how we police ourselves in the form of police data, there's just an absolute abundance of it. And it's not just at the federal level where, of course, we can kind of imagine it. We see it all the way down into cities of 2,000, 1,000 residents even, where every city at the end of the day needs to write checks to buy things. Those checks go to particular vendors. They pay each other. They manage the properties within their boundaries. And of course, we also see that there's a ton of folks willing to really roll up their sleeves and kind of help out. So with that, we'll take a little bit of a detour. Unlike California, we have lots of this, which is water. But I think the story's the same, which is we have a utility company, the water utility in Seattle takes, so our water tends to come up from the mountains. So we've got Mount Rainier and the Cascades, which are rich in water that comes down in the form of rivers and ultimately gets collected in lakes and streams. And then we have this challenge, the water utility does, where it gets piped from its sources, it gets transformed by contaminants being taken out, fluoride being added to the water, and it gets kind of made a little bit more efficient. It gets moved up to the top of hills or on top of reservoirs where we can make sure that there's enough pressure in the pipe when it's actually there. And so in addition to kind of all the public safety reasons we think about when we think about water, which is the ability to have clean drinking water that doesn't make us ill, the ability to put out fires, there's also this kind of huge economic impact that we tend to not consider, which is at the end of the day, a lot of companies make money off of selling dishwashers and laundry machines, as well as taps and tubs and the like. And so why am I talking about this? Well, we at Socrata basically see ourselves as the providers of data, in essence, as a utility. So we access data wherever it is, from the public sector, whether it's, a lone, person in some remote World Bank funded office, in Africa somewhere uploading a CSV or an Excel spreadsheet to, databases, Oracle, SAP, IBM, inside of the government somewhere, or whether it's, a higher level application that, you might pick up the phone and, call and report some suspicious activity in the alley behind your house. It turns out that it's not somebody sitting there with a pad of paper and a pencil writing it down. There's actually an entire 911 emergency response system that's ensuring that that transaction gets recorded properly, that the appropriate resources get allocated, and that they get there quickly. And so we tap into all of that data and we form a pipe to it. And so we've got an API that lets us go in and grab it at its source. We often do things like joining data across one or two or n databases. We do a number of stuff like dropping certain columns in case they're too sensitive to even pull up into our cloud, which Joy alluded to a bit. And then we basically pull the data up into Socrata's cloud. And once it's up in its cloud, we go through an annotation process where we try to extract some higher level semantic meaning around the data. And finally, we start to roll it into specialized index structures. So if we detect the data to be geospatial in nature, we'll move it into geospatial indices. If it's highly textual in nature and we need to be able to power search or really rapid auto-suggest prefix-style queries, then we'll move it inside of an Elasticsearch cluster. And then eventually we pop an API on the consumption side of it. That's a really simple, easy to use REST API. All of this then gets used to power information portals, data portals like the one that Joy just showed. In fact, including the one that Joy just showed. So in addition, we build a number of applications. And I'll talk about a few. They go from high-level applications that help you kind of look at data and get an enhanced version of, in essence, flat tabular data. So we help to provide kind of a survey-level analysis, and we'll go into that, as well as very detailed, specific applications that help address some of these problems that we see in government and some of the things we want, such as increasing trust in government by taking all of the salaries of folks in a particular city and throwing them online, which a lot of our customers do, or taking the entire checkbook of exactly what's written and putting that online. Finally, we power, we make it possible for developers and analysts themselves to build applications. Every day in Chicago, taxi drivers wake up, check their phone, and see if they've got a license to drive a cab that day. It turns out there's a lottery system in Chicago. You don't actually get to drive for sure, even though you get to be in the lottery. And so that's, so whether it's one or two developers or, larger scale development operations like Yelp or Zillow, where a company like Yelp works with us to define a restaurant inspection standard, and then we can now go to our customers and say, hey, look, if you take your restaurant inspection data that we automatically recognize to be, restaurant inspection data, with a few transformations, you can put it into Yelp, and now you will be syndicated into this very large consumer space. And so it allows our customers to really get an audience around their data as well. So who uses Socrata? We tend to think of our customers as being twofold. There are external data consumers, which is everything from citizens asking, like, how good is my school? How safe is my neighborhood? To reporters who are writing data-backed articles. And then we also think of publishers themselves. Joy is very much one of our archetypes here, the chief data officer. We also have mayors, folks in the mayor's office. Someone who may have ran an election saying, hey, I'm going to reduce crime by 5% over the next few years in office. We help to gather those kind of key performance indicators along with candidate predictive correlate variables and put those all in a nice dashboard. So when folks meet once a week to sit down, they can really see, hey, am I looking at the right data? What are we doing to move crime? And can have kind of very data-driven conversations. So once the data kind of comes up into our cloud, we go through sort of an extensive kind of process around annotating the data sets. So for example, we annotate data sets into categories like health or transportation, and more refined categories like infectious disease or taxi-related transportation. We also automatically detect inside of data sets whether things are geospatial in nature. If we've got point data, for example, the location of bike racks in Chattanooga, Tennessee, we want to be able to rapidly select the appropriate polygon boundaries that describe not just the city, but also the maybe the neighborhood boundaries, or if it's a crime-related data set, maybe we want to put a police district boundaries. So we want to reduce that friction so that publishers, when they're pushing this data out, it can be as easy as possible for them to kind of define their experiences. We do things like normalize columns. So if there's 25, 50, 1,000 different ways of calling something a crime type of crime, we want to be able to detect that and normalize that. We do a fair amount of entity detection, an increasing amount of entity detection. So being able to figure out that a column is really a list of people or organizations or more specific or locations. We want to be able to go even further and say, is it city names or country names? A lot of times, folks will, inside of our customers will be scanning data sets across maybe 10, 15 million rows, and they say, hey, look, this looks like uniquely identified people that we've anonymized, but we want to be able to sort of go in there and automatically say, well, but these 15 rows are actually credit card numbers that slipped through for some reason, because this sort of thing does happen. So there's also kind of a broader question around data dictionaries and being able to normalize values, which is a bit of a harder problem. So I'll talk a little bit about some of the problems we face with respect to heterogeneity within the data. All of our customers tend to think of their data as being very special and unique. I think all of us have this tendency when we work with data. But it turns out that there's a lot of patterns that we see in the data. So even though we have many hundreds of crime data sets, for example, at the end of the day, crimes tend to happen at a particular point in time, a particular point in space, and they tend to get classified. Some folks, one city might call it, that column of data that includes the classifications, crime type, another crime category, yet another criminal incidence. And so we'll do things like, leverage a curator who can kind of query and sort of look for, in an index at the column level to be able to identify these things. So we might leverage, synonym relationships around crime, criminality, et cetera, morphology to get a seed set of columns, and then they'll go through there and sort of pick ones that are kind of illustrative of a particular category, in this type, crime type, and then we'll be able to use that, in a machine learning sense to be able to define a set of, a clear kind of positive category, and we do a lot of kind of common texty things where we'll sort of tokenize the column names cleverly, maybe grab the top, n values in there and engineer some features and wind up with sort of a reasonable classification. We tend to think of our machine learning activities in very much in kind of a feedback sense, where we incorporate the turking or crowd sourcing of training data. So for example, when we classify data sets, one of the things that our publishers do when they publish the data sets is they have the option to kind of tell us what the data sets are about. So one might say, this is about transportation. Another one might say this is taxi data. So we'll take those socially provided tags and build really kind of poor performing rudimentary models out of them. And then we'll pass those through sort of a larger set of data and look at the kind of high confidence cases. And then we'll take those high confidence cases out to Mechanical Turk. And then we're able to kind of, in this way, we're able to sort of spend our money very judiciously. The Turkers, we're able to ask very concrete questions like, hey, is this data set about infectious disease or whatever? They'll give us the responses. And then in this way, we're able to sort of build this feedback loop where we've got kind of an increasing level of quality around and coverage on training data sets, and we're able to kind of improve the quality of our models. I'm going to talk about three different kind of types of applications. The first is Data Lens, which is a new product of ours that we just launched a couple of weeks ago. It's the second generation product that in essence tries to take, with relatively minimal context, we have flat tabular data. We might know, a little bit about the data. We might know next to nothing other than column names and values, and we might have some very helpful publishers that provide a lot of detailed metadata. But in general, the task what we do is we'll take these columns of data. So we'll, for example, detect low cardinality text data in a column and decide to go with a bar chart. Right here, we're looking at Malibu, California crime. And we can see at a glance that this bar chart tells us that traffic stops is the #1 type of crime. We'll also detect hey, we've got a bunch of point data. We go off and we pull up the appropriate polygon boundaries. We throw them up, and then we can generate a choropleth map like we see here. And you can figure out sort of rapidly which zip codes have the highest crime. And it's also easy to kind of at a glance be able to sort of detect some level of seasonality. And we also, of course, power some cross-filtering via roll-up tables that we generate automatically on the back end. And we're able to kind of present this sort of intuitive navigation across the data. So I live in Ballard, which is one of the highest growth per capita neighborhoods in the country right now. And so one of the sort of common topics of griping and complaining is all the new condos that the Amazon folks are like bringing to the neighborhood. So I can kind of at a glance go in and check out where building permits are, for example, if this matters to me, and I can see them in my neighborhood. An example of a much more kind of targeted, tailored application is our open expenditures application. So here, this addresses kind of the trust in government issue, or we hope it does. The city of Davenport, Iowa, is sort of offered so in this case, we sort of say like, hey, if you write to this particular schema, in exchange, we can give you something. So in this case, it's a more targeted application that any citizen can go off and access, or any web user. So at a glance, you could see, okay, $80 million spent in 2014, 10 of that on capital projects, 837 on lateral sewer repairs. And here we get to stuff that's pretty interesting, where you can see exactly what the city of Davenport, Iowa spent for who the vendor was, and this is kind of all broken down into kind of highly detailed categories. And any of our users, there's a question around APIs, can now access the data. One of the things that we really strive to do in our apps is have very contextual, like in just about any context that you use the apps, to be able to give developers the endpoints so that they can kind of jump right in to very contextual documentation and everything. With that, I'm going to take a little bit of a detour and talk about a very different application that I think is a little might be of interest. The city of Chicago had a rat problem, and they had a belief, like many cities of that size and scale, that the problem's going to be here for a while. So they staff up a set of fixed resources. So for example, there's a fixed number of trucks, there's a fixed number of traps on the trucks, and there's drivers who drive around and folks who bait these traps. And so they're left with a choice, which is where to put the traps. And so, a very naive approach would be to just kind of randomly put them out in the city, and they'd certainly catch a few rats. Or you could generate a heat map with maybe a time lag, and based on that, you could kind of go look at the hot zones and put the rats in, and you would certainly catch more, or likely catch more than in a random case. But they chose to go further, so they teamed up with Carnegie Mellon University and built out a spatial temporal predictive models. And one of the challenges that they face right away is spatially and temporally aligning the data in the first place. And this is a challenge that we see at Socrata as being able to, so one of the things that we do is we look to our sort of lighthouse cities like San Francisco, Chicago, New York, to see, these are cities that have a little bit more money and are able to fund folks like, statisticians to solve problems. And we like to look to some of those lessons and pull them down to smaller cities, that maybe can't afford that. And so this is one of these kind of lesson cases. So so Chicago, so people, the way it works is you call in and you say, oh my gosh, there's a big rat, behind my house or in my alley, and so that data gets recorded. The address comes into Socrata. We geocode it into a lat long. And so now we have a point on that data. You need to be able to find the candidate correlate variables. So it turns out that rats tend to breed when the weather is nice and tropical, and they tend to die off rapidly when the temperature drops suddenly. If somebody calls in and complains about garbage overflowing in an alley, that's important, but only if it actually happens within a certain radius of where the rat was sighted. And so all this stuff got gathered together. They put together a spatial temporal model. And I bring it up because it was operationalized, and it's actually, so every morning these truck drivers now check this operational, check this model's output, and it tells them exactly where to go and bait traps. And indeed, there's been a significant reduction in rats. So what's the lesson? The lesson from Socrata is, one of the things we really are trying to do is to be able to slice data by time, by topic, and space, and make it possible to kind of build data sets that are appropriate for different folks. So for example, one of the challenges with respect to government data is that it comes in, due to the way government is federalized in much of the Western world, it comes in from different sources. So if you want to build an exhaustive data set, an exhaustive data portal around a geographical boundary like a city or a county, that data is not just originating at the county, nor does that county only want to communicate with their constituents about the data that they generate. So irrespective of whether it comes from city government, state government, county government, the feds, nonprofits, multilaterals, or anyone else gathering data, we want to be able to slice it up, and we also want to be able to slice it up by topic. So I'm going to talk about a little bit about kind of computing against a living data set. So we've been, we heard a great talk by Stephen Wolfram on these lines, and I think we at Socrata want to work with anyone that and really want to power the computation against data sets. We've been working with a local company, a small company in Seattle called Algorithmia, that basically analyzed and just released a little blog post today on building permit data. So they took 6 cities from inside of Socrata, were able to kind of put together a number of models to assess things like the relative seasonality of the city's permit allocations, and using some autocorrelation techniques, they were able to show that, yeah, indeed, cities up in the north have a more pronounced seasonality effect than those in kind of sunny Southern California. And they were able to put together some forecasting models. And I bring this up not because the quality of models is what I'm championing here, but it's this ability for anyone in this room to go set up an account on an algorithmia or comparable service and be able to yank in the data and not just pull it down and take a snapshot of it and analyze it in like SciPy or MATLAB, but to be able to have a continuously live updated analysis or visualization or training on a model, have that hosted by these guys all within a few minutes. So it's a pretty simple process, fully API accessible. So if you want to help out, it's great. I'll end with this last slide here, which is just a touch more detail on once we've annotated data sets, we now have a kind of a more exhaustive understanding of what they are. Leveraging that, we can, for example, take things that are, people, locations, organizations, and route those into an auto-suggest specialized store. And so in this way, Socrata is very much a polyglot store. We aren't looking necessarily for the holy grail. We see ourselves as evolving, as having more and more highly specialized secondaries that handle particular types of data. So with that, are there any questions?
Great, thanks, Steve. Questions for Deep? So I had one, I guess. How much of the work that you do on sort of building these pipelines are sort of end up being city-specific versus completely generic and sort of cross-cutting? And I guess another aspect of the question, how much of the requirements that you're trying to meet, wanting to do sort of comparisons between cities versus just understand one city? For example, is the RAP model something that other people are going to now hope to use in their own city, or is it much too specialized to the constraints of that one city?
Right, so I'll take the first question, which is, what percentage of our kind of ETL pipeline is, city-centric? I would say that, our goal, of course, is to absolutely minimize that, over time. And I think the reality of it is, because we're sort of interfacing in kind of oftentimes highly complex environments, there does end up being a specialization. But we work, with a company called Safe FME, and so we have specialized connectors that we build in. But it ends up being like maybe I don't know, half a page of code or something. And so a lot of the kind of special touches that we have is on the people side. So our client services group that we call customer success will interact with clients. A lot of our clients don't even know where the data is inside of their own organizations, right? Some of these are very large organizations. They can be 17, 18,000 employees. Folks don't even know where data is. Sometimes it's up on a website. So we have a whole process for helping them navigate their own kind of internal channels to identify data, figure out who the stakeholders and the owners are, and get at it. I think a lot of the work ends up being there. Sorry, what was the second question again?
Well, you touched on it a little bit, but when you do end up delivering one of these solutions, is there much a demand from other cities to sort of reuse that, and is that possible?
Oh, yeah, I mean, absolutely. So for example, a lot of our applications tend to evolve, this way. So I mentioned like having lighthouse customers that we look at. So the city of New York spent around $3 million building that open expenditures something very much like the open expenditures application that I showed. So we looked at that. New York was, very eager to take that and put it all up on GitHub, and and indeed the code was put up on GitHub, but other cities, a lot of cities that we deal with don't simply have zero technical people. Like there might be no one, or there might just be a handful. So even taking code out, hosting it, stuff that we oftentimes take for granted. So we put together that application, very much modeled after New York, working with them. In fact, we hired the person at New York who was involved in that and who leads that effort. And now we sell it, for less than around $1,000, $2,000 a month. So way smaller cities can run it.
All right, thanks again.
All right.